So good afternoon, everybody, and thank you, CII, for this opportunity for me to.
Slideshow. Yeah, right. Okay.
Thank you, CII, for the opportunity given to me to present about Industry 4.0. Just to put things into context before I get started, I belong to Tata Elxsi, and we are a product design engineering services company. We've been in business for more than 30 years, and over these last 30 years, we have had the opportunity of working with manufacturers across many industry verticals, as listed here, of which automotive tends to be one of the largest industry vertical that we've been servicing. And what's interesting about us as an organization, and I like what we heard earlier about human industry, we apply human aspects through design to various different touch points when it comes to products, engineering, and more importantly, in the manufacturing space through human factor research and engineering. So with having worked with these kind of companies over the last 20, 30 years, and being associated with the automotive industry over these last 20, 25 years, we've had the opportunity of working with manufacturers going from vehicles which are predominantly mechanical to actually the evolution of an automotive vehicle, which is more sensor based, which is more software and technology oriented. And with that, we have assisted them in deploying technology at various points in time, not just over the last couple of years or not just in context of Industry 4.0, but surprisingly, we have embarked and we have reached a point where these technologies together come and try and address certain problems. But before I go on, what I wanted to do today was to share our perspective and view on Industry 4.0, the challenges associated around manufacturing, and where does Industry 4.0 fit in. And thanks to the co-panelists who have shared quite insightful details of the values, the technologies associated with Industry 4.0. So I'm going to leverage on that. To start with, let me look at a few of the challenges that the manufacturing industry is facing, and some of them that we know. For instance, product recalls and warranty claims. It's not just the business implication associated with this particular challenge is pretty high, not just in terms of financial or economic value, but also the legal, regulatory, and associated, more importantly, the brand image. And it takes time for manufacturers to bounce back from where they are. Take examples of GM, which had 23 million recalls around 2015, 2016, and they had to pay close to 4.5 odd billion. We had Volvo Dieselgate that happened, which led to an pocket change of $1.5 billion to fix the issue. Takata, which was one of the leading airbag supplier, which does not exist today, but had to pay about 1.45 odd billion. And then many recent recalls that have happened even in the Indian context. We've also faced supply chain disruptions. The most recent is the shortage of chipsets. We have manufacturers who have downsized the production. They have hundreds of thousands of vehicles parked in the lot waiting for chips to get delivered so that they can complete the vehicles. And it's not just a pandemic. We have seen this happen. The force majeure situations around floods and earthquakes have impacted supply chain. And then the government's also taking cognizant view of the evolving environmental concerns and bringing out policies to phase out vehicles, to bring more parity to the labor laws, homologation requirements, the end of life management of the vehicles, including the recent policy around recall in India that was announced in April. And over the last 4 months, about 350,000 plus odd vehicles have been recalled from the market, and these are voluntary recalls. Otherwise, they attract a fine of 1 crore and above. A lot of the panelists have also spoken about the fact that there is an increasing expansion of the skill gap. Resource availability is going to be an issue, and with all of these, and there's health and safety requirements, and these are all getting exacerbated because of introduction of automation in the context of manufacturing. But having said that, there is another element which is impacting manufacturing, and that is the changing consumer behavior. As we know, the consumer of today is ever informed, ever connected, ever social, and ever vigilant. The consumer of today and tomorrow is looking for products and services that have positive impact on the planet, and hence they are extremely vigilant of what comes out of the organizations and firms and their impact on the environmental, social, and governance parameters. How inclusive are we as manufacturers? How concerned are we at the social parameters, and do we take care of the carbon footprint? What's very interesting also is that under the guidance of the United Nations, there is this principles of responsible investment, and around the lines of PRI, which has about 4,000 odd signatories, there is an ESG impact fund that has been launched. It's a $1 trillion fund. Surprisingly, only 9% of the fund investment is headed towards manufacturing, and in that, how much of that goes to automotive is still not clear. What it basically means is that more and more we are seeing even investors have got more concerned about the organizations that they invest in, and they tend to require these organizations to present themselves and commit to the sustainable development goals as defined by the UN. So putting things in context, there are a lot of issues and challenges that are impacting the manufacturing segment. It's very interesting to notice that ESG, as put on this slide, is not one of the challenges, but rather I would say a superset of all the other challenges that we spoke about, that I introduced. So what is the way forward? And we all, over the last couple of sessions, have spoken, good things about Industry 4.0. And what Industry 4.0 is supposed to deliver is a digital factory, a smart, connected factory, which is data-driven, which is adaptable, which is flexible, which will help manufacturers deliver superior business and economic value with the greatest customer experience. And of course, the Industry 4.0, being the fourth generation, builds on various different aspects of automation and technology. Now, when you look at the technologies coming together and various sensors and other elements that come together, there are 6 driving principles behind Industry 4.0. And if these principles are appropriately implemented, it would result in a factory that will deliver on the values that we have heard so far. We know the factories have various different machines, tools, systems, and human beings who come together, and they are today talking different languages and different templates. Standardization, templatization of this connectivity and communication will bring all these machines on the same plane. They will make them more interoperable. Interoperability and connectivity will allow data to be accessed from these in a certain format. And this data being collected in real time will allow information to be available at the shop floor, at a manufacturing plant level, to not just visualize, rather than looking at what's happening on a particular machine at a particular given point in time using paperware, but actually looking at a visual dashboard and using the dashboard ability to take decision, while the data is also available for mining the data using machine learning and AI technologies for advanced predictive and preventive maintenance. So there is a level of decentralization, and decentralization will allow decisions to be taken in real time, including decisions that have relevance to the supply and demand needs and requirements, to also participating in a larger connected, cloud connected factory portfolio. And in all of this, the objective is to become more efficient, is to address the challenges of productivity, address the challenges of various supply chain disruptions and the workforce. So creating digital equivalent of the products and services and going all the way up to the plants will allow organizations, manufacturers to mold, adapt to the changing needs, to bring learnings through data, to change the designs of the product, to change the layout of the manufacturing plant, and bring a certain level of modularity. And with all of this, manufacturing would move from manufacturing a particular product at a given point in time to manufacturing a service, where personalization and hyper-personalization might also get introduced over a period of time. These 6 principles, supported by 8 key technologies around cloud, big data, AI, ML, blockchain, cyber security, AGVs, AR, VR, to name a few, together are going to help build the factory of tomorrow, a digital factory. And in the context of the automotive, if you see the connected connection between a vehicle all the way to the factory, a car today is generating close to 500 terabytes of data every second at any given point in time. It's an hotbed of sensors, and with a connected manufacturing plant, you create a digital thread, and this digital thread at in real time allows manufacturers to monitor and track the progress and behavior of a vehicle, the health of a vehicle, and using various different parameters are able to also take certain preventive and corrective actions. Importantly, when you look from a product recall point of view, as you notice a particular vehicle going down, or a particular component of the vehicle going down, because of the digital thread that now gets created, you're able to track and trace from the vehicle to the lot that the vehicle had got manufactured, to the assembly of that particular part in question, the lot of that assembly, to the sub-assembly, all the way to the part and the supplier. In this way, it is very easy to create the compliance map, the quality map, and also take actions immediately rather than waiting till there are damages. And media today is too very hyperactive, which takes things out of context many a times, right? So at a plant level, so we have various different tools, and we have seen panelists speak about various different components and products that they bring together to solve the problems and the equations associated with Industry 4.0. It is just a simple plant view, which goes all the way down from connecting, using sensors and creating connectivity, to collecting data, to using data for visualization at the edge level, going all the way to mining the data and allowing various different decisions to be taken at plant as well as at the corporate level. In addition to this, being integrated with MES systems and ERP allows a much more better end-to-end integration to the supply chain. This is an example of implementing traceability in an end-to-end traceability, creating a digital thread at a plant level. And the right side is a dashboard view, which at any given point in time gives a sense to the plant managers, the shop floor managers, as to what is the takt time, what are the efficiencies, where a particular part is in a given point in time, which machine, what are the interlocking issues, and so on and so forth. This is the similarly, digital twin or virtual creation is not just limited to products and services, but the entire plant can be reconfigured. The plant throughput, the plant product, plant throughput, the plant efficiency, the energy consumption and efficiencies can be monitored and can be addressed by creating digital equivalent of the plant. And in many a times, if it's a green field, then you can use digital equivalent to simulate, to run simulations to figure out the best way to run lean manufacturing. If it's a brown field, you could use these simulations to actually address and bring in the elements of modularity. We've also seen there have been conversations around laxity of capability, and there are quite a few researchers that estimate that by 2028 we would have a shortfall of 2.4 million workers, or rather there'll be 2.4 million manufacturing jobs lacking people. This is going to have an economic impact of upwards of $2 trillion. AR-based solutions are an answer, and we have noticed many organizations, manufacturers over the last year and a half, with especially during pandemic, who have accelerated and deployed these solutions. It is that allows workers who may be relatively less experienced, but are guided through an AR-enabled digital standard operating procedure to do their job. What's more important is also their ability to connect with a subject matter expert sitting in some remote part of the world, who will be able to guide the worker to do their job, applying various different tools and techniques. Similarly, we've also noticed that worker well-being, health is going to be a primary concern moving forward. There are safety and compliance needs and requirements. Application of technologies around AI, ML, video analytics can help track and monitor the well-being of individuals. Here are two examples that we have seen and we worked with customers and put into production, wherein we can actually ensure that a worker, when they enter certain zones, are rightly equipped, and also they can monitor their movements along the plant. Not just this, technology is also being applied from learning, development, training, and development perspective. Here's a reference of work that we did with an manufacturer to create a behavioral and environmental experience center. What's most important is, by putting this together, the manufacturer over the last 2 years has been able to get 50,000 of their employees, both full-time and part-time, trained on an annual basis and get them certified. Very important, because whenever there's a problem on the plant, whenever there's an issue, one of the few things that get questioned is certificates, compliance, regulation. And these data points have helped the client to maintain a low fatality, a much more better and improved compliance by maintaining a digital thread. Similarly, not just from physical, but also creating simulated environments.
Very sorry to interfere. It's only 15 minutes. In case maybe you can help us to cover up, please.
Sure. I think I'll just take 2 minutes and close this, right? So to summarize, there are many such digital interventions, and factory of tomorrow can have all of these, but need not to be the starting point. It can also start from some of these. So from a journey point of view, these are the different levels of business impact, and there's a different level of complexity as you go up. For the data to be collected, you need to start from automation and then go all the way to the IT OT integration for the transformation. And to go there, apply principles of design thinking to work with customers to first figure out what the business function and operational prerogatives are, what the business necessities are, along the lines of some of the parameters that are listed here. And to sum it up, lead to a sustainable future which addresses all the issues around environment, governance, and economics through process integration of human machine collaboration and value chain integration, leveraging these different technologies built on those 6 principles. And to finally, to point out that SDG is the commitment that all manufacturers are making today. Industry 4.0 can address quite a few of these, and these are 6 that can be immediately called out where SDG has a positive impact. With this, I would like to close my session. Thank you so much.